The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to the webinar today. My name is Dimitra Ioannidou and I'm a project manager at ecoinvent. And today I'm going to guide you through an introduction to the ecoinvent database. This is a beginner's guide. It's targeted to people that have a small amount of experience with the ecoinvent database. So let me first of all clarify what is going to be included in the webinar and what will be outside the scope of this webinar, but you can already register for other webinars of this series and get more information. So in this webinar, we are going to focus on understanding the ecoinvent language, how do we read the ecoinvent activity names, to learn what information is provided for every activity, what are the formats available for every activity, and we are going to learn how to read an activity. Finally, we are going to understand when to use markets and how are activities linked between each other in the ecoinvent database. We have received a lot of questions in advance, and I want to clarify that some of these questions are not in the scope of this webinar. However, there are other places where you can have access to some answers. If you have questions specifically about system models, then please register for the webinar Introduction to System Models in the ecoinvent database, which is going to take place in 2 weeks. If you have questions specifically about modeling of sectors, then we are offering webinars on waste sector overhaul, electricity sector updates, and oil and gas in version 3.9. And finally, if you have questions about how to find something on the website, how to download a file, how to access ecoinvent in ecoquery. Ecoquery is the name that we call the platform for accessing the ecoinvent database. It's the ecoinvent tool for accessing the ecoinvent database. So if you have questions about this, for the moment, we have not scheduled a webinar, but there have been webinars in the past, and you can access the recording in the YouTube ecoinvent channel, Documentation and Ecoquery. So the agenda of today, I'm going to present shortly the ecoinvent association and the ecoinvent database. Then I'm going to remind some basic LCA concepts. I'm assuming that most of you, since you're here, you know the term LCA or life cycle assessment. However, I'm going to remind again what this is about. Afterwards, I'm going to go more deeply into the ecoinvent world. I'm going to discuss about activities in the database and how geographies are represented in the database. And finally, I'm going to present transforming and market activities, and we are going to discuss about the linking of activities. We are going to discuss how activities are linked in general, but we are not going to go into a specific system model. This will be included in the webinar of 10 days afterwards. The ecoinvent Association is an association founded by institutes of the ETH domain and Agroscope. We have more than 20 years of experience in life cycle inventory, data compilation, linking and dissemination, and database management. We have as a goal to make available high quality data to many users in the world. And this is something that we achieve by publishing the best available environmental data in the ecoinvent database. We are also supporting people working with ecoinvent data by organizing different events, such as, for example, these webinars. And we promote good practices in lifecycle assessment and in data and database management worldwide. The ecoinvent database is a lifecycle inventory background database that supports various types of sustainability assessments. In essence, the database allows the users to calculate the environmental impacts of their products and services. The database is annually updated, and last week we had the latest release of version 3.9. The current release has more than 19,000 datasets and around 3,200 products. These datasets come from different sources. Industry and industry associations provide data on different sectors. In addition, research institutions and universities are among the data providers, and of course, there are also national initiatives. The data go through an intensive internal and external review process. Internally, they are reviewed many times for compliance and consistency, and externally, they are reviewed by competent editors to make sure that the data are accurate and of the best quality. Now, a reminder of life cycle assessment. Probably you have seen this diagram or a similar diagram in the past. So what is life cycle assessment? Life cycle assessment is a tool to evaluate the environmental impacts of products or services. Life cycle assessment can range through different phases of the life cycle of a product. It can start from material extraction and can go through design and production, packaging and distribution, use and maintenance, and disposal or recycling. The standards ISO 14040 and the ISO 14044 define the main rules for performing life cycle assessments. According to the standards, there are 4 steps in an LCA study: goal and scope definition, inventory analysis, impact assessment, and interpretation, which is happening throughout the LCA study. In this webinar, we are going to focus on inventory analysis. I mentioned before that ecoinvent is a life cycle inventory background database. So I'm going to clarify both concepts now. Inventory means that it's a collection of unit processes. And inventories, a life cycle inventory, can be distinguished between foreground and background data. Foreground data are all the data that are case specific and they can be collected by the LCA practitioner. Let's assume, for example, that you want to perform the life cycle assessment of an aluminium frame. The amount of aluminium included in this frame belongs to the foreground data because it's information that you can extract from this case. You have control over this data. Background data, on the other hand, are average data which are based on LCI databases. The decision maker has no direct influence over this data. In the case of aluminium frame, for example, in the background data belongs the electricity mix used for producing this aluminium, because as a practitioner you do not have influence over this kind of data. ecoinvent is a background inventory database. So having had this very short introduction, let's now jump into what are the activities in the database and how are the geographies modeled in the database. If you have any questions, please feel free to write them in the chat box. At the end of this session or at the end of the webinar, I'm going to go through the questions. An activity is the smallest element in the ecoinvent database. It's a block upon which the whole database is created. An activity represents a unit process of a human activity. An activity has a reference product, which is the main reason for performing the activity. For example, the activity aluminium production produces aluminium, and the production of aluminium is the main reason for performing this activity. In addition, an activity can have one or more byproducts. Activities have also inputs from and to the environment. These are called elementary exchanges or elementary flows. And also, activities have inputs from other activities, from the technosphere. And these are called intermediate exchanges. Now let's see an activity. We mentioned before about the electricity needed for producing the aluminum frame. So let's assume that you are in Australia and you're looking for the electricity mix. One part of the electricity mix is Australia, may be coming from hard coal. So we have the activity electricity production from hard coal in Australia. This has a reference product of electricity high voltage. In addition, it produces as a byproduct hard coal ash. The activity has some inputs from the environment, such as hard coal, the infrastructure needed, and also some other products. It also has input from the environment and some emissions of CO2. In order to better understand how to read the activities and in order to select which activities best represent what you want to model in your LCA study, let's see the nomenclature rules that we follow at ecoinvent. In the activity name, we have a part that indicates the process name, what the process is about. Here, this is electricity production. Then we can also have further specification of the product or the type of technology. Here, this is hard coal, electricity production from hard coal. It could be electricity production from nuclear, from lignite, from other type of fuels. And finally, its activity refers to a specific geography and to a specific point in time. We mentioned before that each activity produces a reference product, which is electricity, high voltage, and refers to a specific geography. We can have the same activity name for many geographies. For example, the same activity of electricity production hard coal exists for Australia, but it can also exist for Belgium. In addition, we can have activities using different technologies but producing the same reference product. For example, electricity production, hydropower, pumped storage also produces electricity high voltage. Now that we saw this general framework about activities, let's look at the geographies, which is one of the main characteristics of every activity. In the ecoinvent database, we have geographies at different levels. We can have activities that refer to the global geography, activities referring to a continental geography, or to a country. We can go even deeper and have activities referring to specific states in a country. For example, here, different states in Brazil. And we can also have activities for customized regions. For example, the International Aluminium Industry Association has specific regions for the activities of aluminium production, and these are also represented in the database. One main assumption upon which the ecoinvent database is structured is that activities cannot overlap, geographies cannot overlap. Let's see, for example, the activities of lime production, milled and packed, which produce the product lime packed. It's a product used in construction. So we have here two activities for RER. This is Europe, and rest of the world. We are going to see rest of the world a little bit later. But for the moment, just let's set it aside and let's look more at the activity, how we avoid activity overlap. If we introduce one new geography, Switzerland, then in this case we would have an overlap of Switzerland and Europe. And for this case, we modify the geography of the second activity so that it's Europe without Switzerland. When you go to the database overview, this is a file that you can download from the ecoinvent website. You can have access to all the activities and products available in each version of the database. There you will be looking at geographies such as Europe without Switzerland or Europe without Switzerland and without Austria. By understanding this rule, you also can interpret better this list of activities that you find in the database overview. If you want to learn more about the database overview, as I mentioned before, you can go to the recording in the YouTube channel about the eco query and the website. Now, rest of the world. What is rest of the world? This is used widely in the ecoinvent database. Rest of the world is considered a geographical area. And the rest of the world datasets can contain data that are not individually represented in the ecoinvent database. Let's see the example of coffee green bean production Arabica. In the database, we have specific activities for Honduras, Colombia, Brazil, and India. These 4 activities represent around 85% of the global production volume. By production volume, I mean the amount of this product, the amount of coffee green bean produced in a year. The rest 15% of the global production is modeled with this rest of the world. So the rest of the world is this difference from the global production to subtract the individual datasets that are specifically modeled in ecoinvent. And in this relationship, we also take into account the production volume. So the production volumes are the weighting factors for calculating the rest of the world. Another example is here the cement production Portland. And this is in order to understand that the rest of the world is very different from activity to activity. In this case, we model as specific datasets around 35% of the global production. So the rest of the world represents around 65% of the global production volume. And here also the rest of the world includes different countries. Even though an activity is the smallest element in the ecoinvent database, still sometimes activities are not fully disaggregated. This can be either because it doesn't really bring additional value to have a very high level of detail, or because data are not always available. For example, an association may not have data for the production of a specific product at a country level, and maybe there is information available at a European level. We can have aggregation either at a horizontal or a vertical level. And our horizontal aggregation means that we can have a geography that is encompassing smaller geographies. For example, Europe contains all the European countries, France, Germany, Finland here, etc. So we have, in many cases, activities that refer to Europe instead of having individually modeled the different countries. We also have, in many cases, vertical aggregation. This happens when, in one activity, we have many sub-steps, and we do not model explicitly each sub-step, either because the information is not available, because they take place in the same location, in the same manufacturing plant, or because it's a very high level of detail for a background database. As an example here, the natural stone plate production activity includes the sub-processes of mining of granite, sowing and cooling, and transportation. For those of you familiar with EPDs, this part here covers the A1 to A3 module. Until now, we saw what we mean when we read an activity name in the ecoinvent database. Also, we saw what to expect from the geographies. Let's see in which format now activities are available in ecoinvent. And this is screenshot from EcoQuery. What I mentioned in the beginning is the platform for accessing the ecoinvent database through the ecoinvent website. If you go to this dedicated area and you log in with your account credentials, you can search for every activity that exists in the database. And each activity, when you select a system model, is available in 4 different ways. There is PDF documentation available. An activity is also available as a unit process. A unit process is gate to gate. This means that on the user side, it allows supply chain analysis and to identify hotspots in a life cycle. And from the ecoinvent side, having the data in a gate-to-gate format allows for consistency of data over time. Because when we update one activity, for example, when we update electricity, then all activities that consume electricity are automatically updated. Every activity is also available in this cumulative LCI format, which is cradle to gate. The information is available in a different format, but it is about the same activity. And of course, we have lifecycle impact assessment results. These are results for many different methodologies and many different types of indicators. If we try to see in a schematic way the difference between unit process and cumulative LCI, then let's see here the 3 activities: activity X, activity Y, and activity Z. Each activity with its inputs and outputs to technosphere and to the environment consists a unit process. It's unit process with a gate-to-gate modeling. Now, activity X supplies activity Y, that supplies activity Z, that produces the product Z. When we look at activity Z, if we want to have a cradle-to-gate modeling, then we are going to go for the cumulative LCI, which means that in this case, we are going to look only at what goes in and out from the environment. And of course, we have the reference product, this product Z. This activity that we saw before, electricity production hard coal for Australia, if we look at it in a cumulative LCI format, is a long list of inputs from the environment and emissions to the environment. And in the eco query, this is the activity of expanded clay production. It's a construction material. This activity has inputs from technosphere and emissions to the environment. It's a unit process. It's a gate-to-gate process. If we look at the same activity but in a cumulative LCI format, then we have a long list of emissions and inputs from the environment. This is just very few of these exchanges. So let me make a short break here and have a look at the questions that we have, and then I will continue with the last part. The slides, yes, you will receive them afterwards. The slides and the recording will be available. The transportation in the ecoinvent database is reported in ton kilometer, which represents the transport of 1 ton of goods over 1 kilometer. What does the value shown represent? So you got it right, that it's basically representing one transportation of 1 ton over 1 kilometer. This value is about so every input and output in this dataset refers to this ton kilometer. So if you have, of course, 5 tons transported over 1 kilometer, then you have to adjust the inputs and outputs. You will multiply by 5. Another question is whether it is acceptable to compare the environmental impacts by just looking at the database values. For example, plastic versus paper performing the same functions such as packaging. This is one of the core questions in a life cycle assessment study, and of course it has to do with the basic assumptions. You have to make sure that you're looking at the same functional unit, that you have the reference product is the same. For example, is 1 unit of plastic packaging and paper packaging performing the same function. So if these assumptions are fulfilled, then you can compare the LCIA, the database values. You have to pay attention, and for this, when you look at an activity in the database, there are the metadata. There is the general comment, the system boundaries, activity start and end. So by looking at them, you can understand what this activity refers to. And when you compare activities, you have to make sure that you compare similar activities that refer to the same functional unit. Are the cumulative life cycle inventories the only ones that cover cradle to gate? Does it mean that others are gate to gate? So here I want to clarify. When you have, for example, the activity of cement production in the modeling is gate to gate. So you have the inputs that come into the cement factory and the outputs, the cement that goes out of the cement factory. This is gate to gate. However, when you are performing the life cycle impact assessment based on the ecoinvent database and you are using a gate-to-gate process, of course, this takes into consideration all the upstream processes that supply your process. So in the cement production, of course, you are considering all the energy, hard coal, natural gas entering the process, etc. But if you want to have a look at inputs from and to the environment, if you want to have this longer list of inputs and outputs, then the cumulative LCIs are the ones that can give you this information at an activity level. How often are the processes updated? That's a very good question. So there is no general answer at a database level, and I would say that it depends. We have processes that are updated very often. For example, electricity is updated every 1 or 2 years, and we have other processes that we update as soon as we understand that they are old, they may not represent the latest technology, there are more data available. Of course, with 19,000 processes in the database, even though we would really like, we cannot have an update of all the processes every 1 or 2 years. And in this regard, when the users can indicate to us like these processes may need updating, that's very helpful as well. It can complement our work which we are doing, but this is already very helpful to send us an email and ask us about updates of specific processes that you know may not represent the current technology. Do you have any tips on reading the supplementary information provided within the datasets? Sometimes there is a lot of information and sometimes there is not, which makes selecting the right dataset difficult. Thank you, that's a very good point. And yes, so we have that builds upon the previous question. In all the data sets that we are updating or creating now, we try to have extensive information in the dataset. We have the general comment that we try to describe all this that is needed for the user. At the same time, we have older datasets, especially ones that come from ecoinvent 2. In these cases, you can have access to the ecoinvent reports. In the ecoinvent version 3, you can have in the documentation section access to reports on different sectors, reports on electricity, on different metals, on transportation. And when you log into ecoinvent version 1 and 2, you also have access to additional reports there. When you open an activity in the ecoinvent database, you have access to the source of information. In the metadata, you see the source of information. And there, you can see where you can find more information in the database, if there is not directly inside the dataset. Another question is how to know what is the scope of an aggregated dataset, if it's cradle to gate or gate to gate. Cradle to gate and gate to gate is clearly distinguished between unit process and LCI. So when you select a unit process, which can have different names in the software tools, but it's always called with the same name. So unit process is always gate to gate, and LCI is always cradle to gate. Now, in order to understand the aggregation, for example, the horizontal or vertical aggregation, this is something that you can look at the documentation inside the dataset. You can see, for example, in the natural stone plate production dataset, you would read that this covers the system boundaries cover the input of materials from the mining, from the extraction, up to the um, the point where these are available to be transported to the market. Who verifies your data? That's a very nice question. Thank you. As I mentioned before, first of all, we have the internal review, which is made for consistency and compliance. And we also have external reviewers. These are independent reviewers. They are experts in their area, and they are performing the review of all the data sets. Each sector has, of course, a different reviewer. And in the ecoinvent website, you can have access to the editorial board, who are these external reviewers. How do you make sure the data from the associations are correctly representing the reality? For example, the increased methane emissions. That's a very nice question. The oil and gas industries don't want to have this updated. So, first of all, I see oil and gas, and um, I invite you to register for the oil and gas webinar in around a month. That's where you will learn more about specifically oil and gas. Now, in general, yes, that's a very valid question. And what you will see in the ecoinvent database is that we do not have the same association data that maybe exist in some other places available. This is because when the data are submitted in ecoinvent with these two review rounds, we first of all want to make sure that the system boundaries are consistent in any case, and also whenever we detect, for example, issues with methane emissions in oil and gas, with carbon sequestration, etc. This is something that we have access to a lot of experts, especially in the academic and research institutions. We have a lot of experts collaborating with us, and that's where they come in, and we try to find the best way to model this. So let me now move forward to the last part, and I will address the rest of the questions afterwards in order to make sure that we cover everything. Now, the last part is about transforming versus market activities and the linking of activities in the database. In the ecoinvent database, we have two different types of activities. This separation serves to distinguish between two different needs. These are the transforming activities modeled with red and the market activities modeled with blue. And for all activities that have to do with waste, with treatment, we have specific type. We have the treatment activities and the markets for treatment. A transforming activity is what we have seen until now in the representations is an activity that transforms inputs so that the output of the activity is different from the input. An activity has inputs and outputs from technosphere and from the environment. I mentioned before the cement production activity. So this activity, this is a gate to gate, as I said before, has inputs from technosphere, clinker, electricity, and the infrastructure, among others. Of course, this is not complete. And the reference product is cement Portland. Now, the markets, they do not transform their inputs. They simply transfer the intermediate output from a transforming activity to the transforming activities that consume this as an input. So basically, what happens is that we have the same product going in and coming out. What is added is emissions and transport. Let me explain more with the example of cement. In the case of cement production that we saw before, the product is leaving the production facility. So the product has all the impact from the production. In the case of the market, in addition to the production impact, we also add the impact of transportation. So markets have to do with consumption. They represent consumption mixes. If you are purchasing cement for your construction project, then you are purchasing cement from the market. If you know the exact transportation distance from a specific plant, because you are purchasing from a specific plant the cement bags, then you can model yourself the transportation distance. However, as an average, and since in many cases you may not purchase from a specific plant, the markets have average transportation distances for the geographies that they model. Another example is for electricity. We had in the beginning the electricity production high voltage transforming activity. And here we have the market for electricity high voltage, which transfers electricity, integrates the information on the electricity production, also has information on the transmission network, and has some emissions. The emissions happening during the transmission of electricity from the plant to the consumer. This is how it looks like in EcoQuery. We have in the unit process a reference product, here electricity high voltage, with 1 kilowatt hour as a unit. And what is interesting here is to see that we have a representation of the losses. Markets represent also losses. The electricity in this case that is lost during transmission. And I will not go into the system models. So this is an undefined representation of this unit process. This is something that we are going to cover in the next webinar. It's, let's say, an unlinked dataset. So this 0.0282 are these losses exactly that happen during transmission. And another, in addition to the markets, we have market groups, which are datasets that combine markets of smaller geographic areas into a larger one. For example, here we have market for diesel for Switzerland and market for diesel for Europe without Switzerland. They are both producing diesel, of course. And we can have a market group for diesel for the whole Europe. And now that we have seen about the elements, the blocks in the ecoinvent database, let's see how these are connected to form supply chains, which then are used when you are selecting an activity in the database, there is a supply chain linked to this activity. Activities are linked either through markets or directly with direct activity links. When we have linking through markets, now let's see this through an example. We have soybean production in 2 states of Brazil, and both activities produce soybean. Then we have a market for soybean for Brazil, and both activities supply this market. And the market then supplies any activity consuming soybean in Brazil. The way that the transforming activities supply the market is in proportion to these production volumes. The production volumes, as I mentioned before, is the amount of soybean produced per year. So in this case, the soybean production in the first activity has a much higher contribution to the market because it has a higher production volume. I touched upon this question a little bit before, but let's see it again. If you ask me, should I always use markets? Then I would say it depends. It depends on the case. For example, in the previous case, markets were a very good representation of the soybean supply chain in Brazil. For polyethylene production high density, in this case, let's assume that we have 2 activities for Europe and for rest of the world producing polyethylene. They both supply a global market for polyethylene. And if we now have an activity in Germany consuming polyethylene, then this activity will be supplied by the global market. This is based on the linking algorithm. However, in this case, we may be introducing more uncertainty because Germany is included in Europe. So by including in the supply chain rest of the world the impact of another geography, we are increasing the uncertainty. And in this case, we may prefer to use a direct activity link. We can have the European activity directly supplying the German silicon production activity. And of course, here we need to add transport, which is the information that otherwise is included in the markets. And finally, the last topic that I want to cover in this webinar is related to treatment activities. We saw before about transforming and market activities, and I mentioned that for the case of waste, for the case of treatment, we have special type. A treatment activity is a transforming activity with a reference product with a negative sign. The reference product, repeating again, is the main reason for performing an activity. The main reason for performing this treatment activity is in order to treat this waste paperboard. So this is why it's a reference product. And the activity provides the service of treating or disposing of the reference product. Now, the negative sign is added because, in fact, the waste paperboard in the physical world is an input in this process. So in order to maintain mass balance, that's why we have the waste paperboard modeled as a negative output. And in a similar way, when we have activities that produce waste, for example, here, glass wool mat production produces waste paperboard, this is modeled as a negative input. And similarly to the ordinary transforming and market activities, we have markets for treatment. markets for waste, which represent the mix of waste treatment options. For example, here the market for waste paperboard provides the service of treating the waste paperboard through two different options, incineration and sanitary landfill. And of course, we have transportation included in the markets. So just to wrap everything up, to connect what we have seen until now about the activities, the linking of activities, the modeling of waste with a negative sign, let's see this example, which is a short supply chain that is in the ecoinvent database. Glass wool mat production is a production activity. It produces glass wool mat. This is an insulation material used in construction. The activity has some inputs from Technosphere, like glass, cullet, sorted, some water, some energy. And in addition to the reference product, it also produces some waste paperboard that may come out of the packaging needed for this process. Waste paperboard is a waste, so it's modeled as a negative input. And in this supply chain, we have the link to the market for waste paperboard, which provides the service of treating of waste paperboard through municipal incineration and through sanitary landfill. I will not go further in this because then we are going into the system model discussion and who is bearing the burdens of the treatment. So, wrapping up, some key points when using the database in your life cycle assessment is that multiple activities can produce the same product. All activities are provided in a unit process or gate-to-gate format and in a cumulative LCI format. Markets contain information about consumption mixes, and wastes are modeled with a negative sign. And just to go back to the initial example that I presented about the aluminium frame and how if you wanted to use an aluminium frame in your LC study, how you're going to find the information. So if you want to use aluminium, then again, using EcoQuery, you access EcoQuery with your credentials and you look for aluminium. There is a long list of available activities that produce some aluminium product. If you know more information about aluminium, if you remember in the beginning, we discussed about the specification of the product or the type of technology. So if you know further specification, for example, here, if you know that it's a primary aluminium coming from virgin materials, not recycled with any recycled content, then you can filter for primary. And you have to decide then whether you want to select a market or a production activity. So let's assume that you want to select a market activity, you do not have further information about specific transport. You have to look at the available geographies. Here, in the case of aluminium, if you remember, we mentioned that we have customized geographies for the International Aluminium Industry Association. You can look in the metadata what this geography, for example, includes. So after you select the activity and the geography that best represents your case, then you can also decide how you want to access the dataset in a unit process format, in a cumulative LCI format, or you just want to look at the impact assessment results. And with this, I want to thank you all for your attention. I know that there have been a lot of new topics, information, etc. I see that there are now a lot of questions. I will try to address as much as I can, and then the rest of the questions, I will address them separately in an email. Does a product market activity include its transforming part? Yes. Yes. When we have a market, then a market always includes a transforming activity and the transportation. Which dataset should you select if you know the specific transportation distances but do not want to include the infrastructure, which is included in the transformation dataset? In this case, of course, you can select, so if you are using tool outside the ecoquery, you may modify a dataset in ecoquery. You have two options. Either you will look at the inputs that you have in the activity of your choice, excluding infrastructure, and you will model these inputs as a whole list, and then you will find, of course, with the amounts that you will take from the activity, and then you will find for every case the impact assessment of all these inputs one by one. Or you can calculate, you can include the transforming activity and subtract the impact of infrastructure. How is recycling handled in the model? For example, the glass wool makes use of some recycled glass. Does the recycled glass have no environmental burdens associated with it? So that's a very good question. It touches upon the system models because this has to do with value choices in the system models. In the case of cutoff, for example, in the cutoff system model, the recycled glass has no environmental burdens associated with it. It comes out of the primary life cycle burden-free. But this is something that depends on the system model. So we are going to discuss more about this in the system model. What is the impact of negative inputs? For example, no environmental burdens for negative inputs. So this depends on the case. If we have a waste as a negative input, then, and again, it depends on the system model, the value choices that we make. In the case of cutoff, if we have a waste, then according to the polluter pays principle, if somebody is producing a waste, they are responsible for the treatment of waste. So they have the impact of the environmental burdens of the waste. If they produce a recyclable, which again in ecoinvent is modeled as a negative input, then recyclable is burden-free, and then they have no impact for this. Again, this is going to be further addressed in the system model discussion. A question is about the market datasets. Whether I can explain further what they are, and whether it's aimed to be used when transportation of a product is unknown. But by looking at the documentation, some of the market datasets indicate that they don't include transportation. So in general, markets include transport. Out of the top of my mind now, I cannot really remember which markets do not include transportation. But if they do not include transportation, it's either because there is no transportation involved, because if it is a market group, market groups do not have transportation. Markets have transportation. Market groups just aggregate markets. So, in general, and except if there is a specific case, yes, when you use markets, you always have transportation included. So you do not need to add transportation. That's the reason why markets exist. There are also some questions about specific sector information, for example, about plastics data and methane emissions, which I will address in an email, and also about a question about carbon sequestration, soil transpiration, and organic matter in agriculture. And with this, I also see that there is a question about the advantage over other available databases. I do not want to go into a direct comparison on this webinar. Of course, you can have access to our webpage, or this is more a discussion with the sales people, but feel also free, if you have any questions, to get in touch with us either through sales or through the support page. We have a support group that we try to address any questions that exist. If you come with us about any question that you have on the ecoinvent database, we try to come back to you within just a few days' time. And with this, I would like to thank you again for being here today, for either starting your day or having a nice end, hopefully end in your day. And I am looking forward to seeing you in one of the next webinars. Thank you very much.